Once again, welcome back to the Math Revision Made Meticulous video series. Topic: Application of Derivatives, Local Maxima and Minima. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answers. Let us see what you mean by maximum value of a function at an interval. A function f of x said to have a maximum value in an interval if there exists a point c such that this f of c is greater than f of x for all x belongs to that interval. The number f of c is called the maximum value of f. That is, the value of the function at c is called the maximum value of f, and the point c is called the point of maximum value. Therefore, maximum value of f of x in sin x is 1, and then you are seeing in the graph also from 0 to 2 pi, when you take the maximum value obtained by sin x is 1. Suppose you have minimum value, the same definition. There exists a point such that the functional value at c will be always less than f of x. The number f of c is called the minimum value, and c is called the point of minimum value. Is a point of minimum value. Now you are seeing here that for sin x, minus 1 is the minimum value. For all of you know that maximum value of sin x is 1 and minimum value of sin x is minus 1. Let us see what is the meaning of extreme values. A function f of x said to have an extreme value if there exists a point c such that f of c is either a maximum value or minimum value. The number of c is called the extreme value and the point c is called the extreme point. We are calling this as a extreme point. What is the extreme value of f of x in the interval are 1 and minus 1. Therefore, one extreme is 1 and another extreme is minus 1. Well, for the function f of x is equal to x square, sometime we may have a doubt whether a particular function will have always maximum value, always extreme value. Now the minimum value is 0 for this f of x is equal to x square, but it has no maximum value as it is infinity. Now you are seeing that whatever the minimum value is at the origin, but the maximum value it goes up, therefore there is no maximum value. And similarly, for the function f of x is equal to x square, when you take from minus 2 to 2, suppose if you restrict it, that f of x is equal to x square for the whole number line, for the whole real numbers, but if when you consider that f of x is x square only for x range from minus 2 to 2, then you will have the minimum value and always you will have a maximum value also. If you restrict the domain, you will have minimum and maximum value. And suppose if you take the function minus 2 less than x less than 2. Now remember, it will have a minimum value but no maximum value because it is not less than or equal to x or less than or equal to 2. Therefore, no maximum value because if you take any real number less than 4 as maximum, we can find another real number more than that. Therefore, for this function, you will not have a maximum value even though it is a restricted domain. Now when you take the function minus x square, the maximum value is 0 and minimum value is minus infinity because it goes down. Well, now when you restrict it to minus 2 to 2, then its maximum value is 0, minimum value is minus 4. But when you take minus 2 to 2, it has maximum value 0 but no minimum value because it is not a closed interval. Well, now let us take a question. How to find the maximum minimum value of the function? Very simple. You have to check the range of x for which f of x will be maximum. How to do it? You have to take this is a x minus 2 whole square form. It is always greater than or equal to 0. Therefore, minimum value will be obtained when x minus 2 is 0. Therefore, x is equal to 2. But minimum value is 0. F of 2 is 0. And no maximum value because whatever the value of x you are putting, it will be going up and up. Therefore, minimum value is 0 and maximum value is no. Therefore, we are seeing the graph of it, and this is the upward parabola. It touches the origin at 2, 0. Therefore, its minimum value is 0 at x is equal to 2 and no maximum value. Now, let us go to questions now. First type of questions will be, they want you to find the maximum minimum value of a function simply given to you. It is not local maximum minimum, it is a general one. Therefore, how to get it now? F of x is given to you. Try to check the nature of the function. For example, x minus 1 whole square is greater than or equal to 0. Minus x minus 1 the whole square will be less than or equal to 0. When you add plus 10 to it, it will become less than or equal to 10. Therefore, the maximum value will be obtained because less than or equal to. Therefore, maximum value will be obtained when this x minus 1 is 0. Therefore, x is equal to 1. Therefore, maximum value is by putting x is equal to 1, that is f of 1 is a 10. But it has no minimum value. It has no minimum value because when whatever the value of x you are putting is going on down, down, down. Let us see its graph of it. You are seeing the graph. It is a downward parabola and its maximum value is 10 at obtained at 1 comma x is equal to 1 and it no minimum value because it is going down, down, down to 2 minus infinity. Let us move on to question number 2. Find the maximum and minimum value of the function if any. F of x is mod sin 4x plus 3. Let us try to get the problem by making use of the property of trigonometric function and the property of modulus. Okay, f of x is modulus sin 4x plus 3. I will start with sin 4x. Sin function lies between minus 1 and 1 only. Therefore, when I add 3 to it, therefore minus 1 plus 3 less than or equal to sin 4x plus 3 less than or equal to 1 plus 3. But you are having modulus. When I take the modulus, left hand side will become 2 less than or equal to modulus less than or equal to 4. For left hand side and right hand side, it lies between 2 and 4. Therefore, maximum value is 4 and minimum value is 2. F of x lies between 2 and 4. Let us see the graph of it. This is the graph now. You are seeing that graph modulus sin 4x plus 3 going up, coming down, going up, coming down. It goes up to 4 in the y-axis value and then it comes up to 2 in the y-axis. Therefore, the value of f of x is minimum 2, maximum 4. Well, let us see what do you mean by local maxima and local minima. F of x be a real valued function, c be a interior point and c is called the point of local maxima if there is h greater than 0 such that f of c is greater than f of x for all x in the c minus h comma c plus h. They are telling that the c plus h comma c minus h is a neighborhood, a small interval around that h, around that c with h greater than 0. In that you should get it satisfied. And the value of f of c is called the local maximum value. For local maximum will be obtained at critical point. Local maximum value of sin x, what do you want? It is 1, already we have discussed. Local minimum value is the same thing. If it is a real valued function and c is a interior point, then this f of c will be always greater than f of x in a neighborhood of that c, that is c minus h comma c plus h. And the value of f of c which you are finding is called the local minimum value. Well, this is the local minimum value of sin x is minus 1. Now, nature of derivative at the point of local maxima or local minima. What will be the nature of the derivative? If you get a function and in the open interval you are defining, then f dash of c is equal to 0. The meaning is the derivative will vanish at the point of local maxima or local minima. A point at which the derivative vanishes need not be a point of local maxima minima. That is another idea. Anyway, let us see that f dash of x, suppose you know that maximum minimum value of sin x. Let us check whether it f dash of x vanishes. Let us see. Now I am taking both the functions now, f of x and f dash of x. F of x is sin x, which I have give it in that red color, and f dash of x is given in the blue color with the dotted lines. And you are seeing that is cos x is 0 at all points of local maxima and minima. Whenever you are getting local maxima minima, you are getting it at pi by 2, then 3 pi by 2, 5 pi by 2, then minus pi by 2, minus 3 pi by 2. At all these values, the cos x function crosses the x-axis, which means that it vanishes. F dash of x is equal to 0. Well, now let us take another problem. Sometimes a point may not have be neither a local maxima nor a local minima. This is the example for it. For the function f of x is equal to s cube, the derivative is 0 at x is equal to 0, but x is equal to 0 is neither a point of local maxima nor a local minima. You are seeing that it just crosses it. Well, now as if we know that f dash of c will be 0, that is at the point of local maxima and local minima, the derivative vanishes. These points are called critical points. A point c in the domain of a function such that f dash of c is equal to 0 or f of x is not differentiable is called critical point. At the critical point, the tangent is parallel to the x-axis. At the critical point, the tangent is parallel to the x-axis. That is why f dash of x is equal to 0. Anyway, now we are seeing over here, once again, the cos x function we are taking. Now at these points, you are seeing that the tangent to the curve is parallel to the x-axis. Okay, anyway, this is only information. However, at the critical point, f dash of x vanishes and the tangent is parallel to the x-axis. Well, let us find there are two types of tests to find the local maxima minima. One is called first derivative test, another is called second derivative test. Let us see first derivative test first. Let us f of x is continuous and f dash of x is greater than 0 at every point sufficiently close, then C is a point of local maxima. If f dash of x changes from positive to negative as x increases to 3, then C is a point of local maxima. F of C is called the local maximum value. Now how to get the first derivative test? You first find f dash of x, equate it to 0 and get the critical point, because at the critical point only local maxima and local minima exist. Consider a critical point x is equal to C and take point one in the left of C and another in the right of C. They are very close to C. For example, if you have 2 as a critical point, take 1.9 and 2.1. If you have 4 as a critical point, take 3.9 and 4.1. Be careful when you take a problem with minus. Suppose if it is minus 2, you take minus 2.1 and minus 1.9. One in the left, one in the right. Well, check the sign of f dash of x at these points. Suppose it changes from positive to negative, then it is a point of local maxima. That is f dash of c plus h is greater than 0 and f dash of c minus h is less than 0. Positive to negative. Now I will take one question and tell you that how this first derivative test is useful. I am taking f of x, I am differentiating, equate it to 0, then I will get the value of x as 2. What are the points I have to take? 1.9 and 2.1. Now I take 1.9 and 2.1 very close to 2. I first find f dash of 1.9. Now from the calculation itself you are checking that it is greater than 0. When I take 2.1, that 2 into 2.1 will be greater than 4, therefore it will be negative, but 2 into 1.9 is less than 4. Well, therefore it changes from positive to negative, therefore is a point of local maxima. How to get the local maximum value? F of 2 is 1 by 2. Well, now you are seeing the graph of it. The graph of it, the local maximum value is at x is equal to 2 and the local maximum value is 1 by 2. It goes up and then start coming down, therefore you are getting it. Okay, well, and you are checking that f dash of x is always there and it is also being shown there. Well, now first derivative test to get local minima, there we saw that if it changes from positive to negative it is local maxima, if it changes from negative to positive it is local minima. Let us take one example. How to do it? Find f dash of x, solve f dash of x is equal to 0 and get the critical points, and consider a critical point and take 2 points, one in the left and one on the right. Already we have discussed. Check the sign of f dash of x. If it changes from negative to positive, suppose at c minus h it is negative and c plus h it is positive, then it is a point of local minima and it is called the local minimum value. Let us take one example. We have to take 2x square minus 30x plus 225 and f dash of x I am finding equated to 0, I am getting 15 by 2. What is 15 by 2? It is 7.5, where I take 7.4 and 7.6. Let me find what is f dash of 7.4. It is coming as less than 0 and f of 7.6 coming as greater than 0. Therefore, f dash of x changes from negative to positive. Therefore, it is a point of local minima and the minimum value is 125 by 2. Now we can see the graph of it also, and its graph is like this. It's coming down and then going up. When it comes down at 7.5, it is getting the local minimum value. Remember, at the local minimum value, the function will start increasing. At the local maximum value, the function will start decreasing. Well, now we know that we have found what is local maxima, how to find it, how to find the local minimum, local maxima. But there is one more point, is called point of inflection. What is it? If f dash of x does not change the sign. Now already we have seen, if f dash of x changes the sign from positive to negative, local maxima, negative to positive, local minima. Actually what really happening is the slope of the tangent is changing from positive to negative and negative to positive. Well, If it does not change, then C is neither a point of local maxima nor a point of local minima. We are not able to decide it. These points are called point of inflection. Let us see this example. I am getting f dash of x. I am equating it to 0. I am getting x is equal to 1. What are the point I have to take? I take 0.9 and 1.1. F dash of 0.9 is also greater than 0. F dash of 1.1 is also greater than 0. Therefore, the sign does not change. Therefore, is a point of inflection. And you are seeing that the point of inflection means just come and goes up. Therefore, it is a point of inflection. Well, let us move on to the second derivative test. The first derivative test is actually very strong. It is having checking the value of f dash of x. Sometimes f dash of x, if it is having a lot of terms, very difficult for you to get the sign of it. Therefore, second derivative test is very simple. Again, second derivative test, what we have to do? It is twice differentiable, then only we can use it. If f dash of c is equal to 0 and the second derivative at c is less than 0, it is a local maxima, and f of c is called the local maximum value. What you have to do? You have to find f dash of x and put the critical point there. If the second derivative is negative, that is a local maxima. Now, local maxima is find f dash of x, solve f dash of x, get the critical point. Then consider a critical point and then check the sign of f double dash of x, and if it is less than 0, point of local maxima, and f dash of c, then c is the point of local maxima. Remember, this second derivative test can be applied only when the second derivative is available. Now let me take one example. Already we have took this example. Let us find how the second derivative is very easy. I find f dash of x, I find f double dash of x, it is less than 0, and I am putting x is equal to 1 there. There is no change there because f double dash of x is a constant. It is less than 0. Therefore, at x is equal to 1 is the point of local maxima and the value is 1. And you are seeing that function here. Now it is having a local maxima because there at 1 comma 1 it changes from increasing to decreasing. Well, now second derivative test, how to check the minima? The same thing. Find f dash of c is equal to 0, get the critical points, and check whether the second derivative is negative or positive. If it is positive, it is a point of local minima. Then f of c. Now how to get it? Step number 1, find f dash of x, solve f dash of x is equal to 0, get the critical points. You just take a critical point and then check the sign of f double dash of x. Suppose f double dash of x is greater than 0, it's a point of local minima. Then the value is called the local minimum value. Remember, you have to put it in f of c to get the minimum value. Well, now we will take one question now, local minimum value. 2x minus 4, f dash of x is equal to 2. And when I put x is equal to 2 in f double dash, then I am getting the value as 2 and it is greater than 0. Therefore, local minimum value is minus 4. And you are seeing the graph of it. This graph is very simple. You are getting the local minimum value as minus 4. And you are checking that at the local minimum value, it changes from decreasing to increasing. Second derivative test, you have to be very careful. Suppose if f double dash of c is 0, then the second derivative test fails. Automatically you know it. In that case, we use the first derivative test. No other way out. Suppose if second derivative test fails. When it will fail? Suppose if f double dash of c is greater than 0, local minima, less than 0, local maxima. But if it is 0, we are not able to take any decision. At that place, second derivative test fails. Okay. Now we are taking one question. F of x is equal to x cube. Here I am getting f double dash of x is equal to 6x. When x is equal to 0, I am finding f double dash of 0. It is 0. The second derivative test fails. What you have to do now? You have to go for first derivative test. I take minus 0.1 and 0.1. I am getting that greater than 0 to greater than 0. For again, first derivative test also tells that sign is not changing. Therefore, it is a point of inflection. Very interesting question. You are seeing that f of x is equal to x cube, that x is equal to 0 is a point of inflection. Now, how to select? Use second derivative test for function given as polynomials or trigonometric functions. When polynomial is given and trigonometric function is given, you go for second derivative test. It will not be mentioned in the exam. They will ask you find local maximum only. You have to decide. and use first derivative test if the second derivative test fails. Already we saw an example. And if the second derivative is lengthy, suppose if you feel, sir, second derivative test is having u by v form, having square root, so many terms are there, better go for first derivative test. Therefore, second derivative test, if it fails, go to first derivative test. And otherwise, if it is a polynomial or trigonometric function, better use second derivative test. Well, let us go to question now. Question number 3. Find the local maxima and local minima. This is a polynomial. Quickly we will see. F of x is given. I am finding f dash of x. I am finding f double dash of x is also, and keep it ready. And I am equating it to 0. And I am solving it, factorizing it. And I am getting x minus 3 into x minus 1 is equal to 0. When I factorize, f dash of x is equal to 0. Therefore, I am getting the values as 1 and 3. What you have to do now? I have to take the point 1, I have to take the point 3, and I have to check the sign of f double dash of 1. For x is equal to 1, f double dash of 1 is minus 6, less than 0, the point of local maximum. Therefore, local maximum value is f of 1. Be careful, maximum value means you have to go to f of x, for the value is 19. Let us go to the next point 3. Again find what is f double dash of 3. The answer is 6. Therefore, this is greater than 0. It is a point of local minima. Minimum value is 15. No need to tell you that maximum value should be greater, minimum value should be smaller. You are getting that maximum value 19, minimum value 15. Well, this is the curve of it. This is a cubic polynomial. Therefore, you are seeing that maximum value is attained at x is equal to 1, that is 19. Minimum value is attained at x is equal to 3, that is 50. Good. Let us go to next question. This is a question of trigonometry. And whenever trigonometry given, all of you know that they will give you the range 0 to pi by 2. Let us find. Sin x plus cos x is a given function. I am differentiating it. I am finding the second derivative, keep it ready. Equated to 0. I am getting cos x is equal to sin x. For tan x is equal to 1. X is equal to pi by 4. Remember, the given range is 0 to pi by 2. That is why I am getting only pi by 4. In the exam, suppose the range is changed from 0 to pi or 0 to 2 pi, you will get more values of x. You should be careful. Well, I am taking only the critical point pi by 4. Let me check the nature of h double dash of pi by 4. It is coming as minus sin pi by 4, minus cos pi by 4. Therefore, it is, less than 0. Therefore, at x is equal to pi by 4, it is the point of local maxima. What will be the maximum value? You have to put it in h of x. Therefore, the value is root 2. Now, let us see the graph of it. And I have taken only a part of the graph, sin x plus cos x from 0 to pi by 2. Here you are seeing that it goes up to that pi by 4 comma root it goes. That is the local maximum value. The value is root 2. Let us go to next question. Find the point of local maximum and local minima and the corresponding maximum minimum value for f of x is sin power 4x plus cos power 4x. Very famous problem in CBSE. Here remember, after the first derivative you have to simplify, then only you will get the critical values. Let us see. Normal differentiation of chain rule. 4 sin cube x and the differentiation of sin x is cos x. 4 cos cube x differentiation of cos x is minus sin x. Or I write it as minus 4 sin x cos x. Take it out. Cos square x minus sin square x. It is minus 2 into, I am writing 4 sin x cos x as 2 into 2 sin x cos x and cos square x minus sin square x. You know the formula. Sin 2x is 2 sin x cos x. Cos square x minus sin square is cos 2x. I continue. This is minus sin 4x. You see how this f dash of x is simplified. Otherwise, you cannot find the critical points. However, please note down the simplifications. Okay. Now, differentiating again with respect to x, I am finding f double dash of x and keep it ready. And I want to find the critical points now. For that, f dash of x is equal to 0. And sin x is 0 means x is n pi. Therefore, sin 4x is 0 means 4x is n pi. But here we have to select those values which will serve me the purpose. X lies between 0 and pi. Therefore, 4x lies between 0 and 4 pi. Therefore, you should take only those values of 4x for which it is sin 4x is 0. What are the values will come? Only pi, 2 pi and 3 pi. These are the only 3 values lying between 0 and 4 pi, which are the multiples of pi. But don't take this directly because we need the value of x. X is pi by 4, 2 pi by 4 and 3 pi by 4. What is 2 pi by 4? It is pi by 2. be careful. Critical point getting is highly critical in this problem. You have to find the critical points carefully. It is pi by 4, pi by 2 and 3 pi by 4. Now your work starts. We have to check the nature of f double dash of x at these points. I take pi by 4. I am getting minus 4 cos pi. Therefore, it is greater than 0. Therefore, it is a local minimum value because it is greater than 0. Therefore, local minimum value is given by sin power 4 pi by 4 plus cos power 4 pi by 4. 1 by 4 plus 1 by 4. The answer is 1 by 2. Let us take the next value now. We have to take pi by 2. F double dash of pi by 2. It is minus 4 cos 2 pi. Cos 2 pi is 1. Cos pi is minus 1. Cos 2 pi is 1. Cos pi is minus 1. Cos 2 pi is 1. Well, therefore, it is less than 0. Therefore, it is a point of local maxima. I will put x is equal to pi by 2 in the function. So, sin power 4 of pi by 2 plus cos power 4 of pi by 2. Sin pi by 2 is 1. Cos pi by 2 is 0. The answer is 1. Let us continue. Let us try to get the value of f double, check the value of f double dash of x at 3 pi by 4. It is minus 4 cos 3 pi. 4 and 4 get cancelled. For cos 3 pi is minus 1. Cos pi minus 1. Cos 2 pi plus 1. Cos 3 pi minus 1. Therefore, you are getting minus 4 into minus 1 greater than 0. Therefore, it is a local minimum value. The local minimum value is given by f of 3 pi by 4. We have to find sin of 3 pi by 4. I am giving you the value. It is sin pi plus pi by 4. It is in the second quadrant. Sin is positive. Therefore, 1 by root 2. Cos pi plus pi by 4. It is in the second quadrant. Cos is negative. Therefore, minus 1 by root 2. Therefore, 1 by root 2 the whole power 4 plus minus 1 by root 2 whole power 4. Once again, 1 by 4 plus 1 by 4. The answer is 1 by 2. Therefore, you got the value f of pi by 4 1 by 2. You are seeing over there. F of pi by 2 is 1 and f of 3 pi by 4 is 1 by 2. And you are seeing that the maximum, local maximum value is obtained at pi by 2 and minimum value is obtained at two places, that is pi by 4 and 3 pi by 4. Well, okay, success is dependent on the efforts. All the best. Thank you.